This is Fred. Fred is going on an airplane to visit colleges. He packs his suitcase and gets on the airplane. When he arrives, he opens his suitcase and finds that his shampoo has leaked everywhere. What made the shampoo leak? To explain this, let's talk about fluids and pressure. A fluid is the main focus of this unit. It is any material that flows, liquid or gas. It takes the shape of its container. A liquid fluid has molecules that are as close together as they can get, meaning it is incompressible. A gas is a fluid whose molecules are far apart. It is compressible. When Fred packed his suitcase, he sealed his shampoo bottle. Inside was shampoo and air. The air molecules at sea level move very quickly, 500 meters per second on average. That's about 1,100 miles per hour. In Fred's shampoo bottle, we can measure the collisions of the air molecules with the container walls by measuring pressure. Pressure is the force per unit area. The equation for pressure is pressure equals force divided by area. Note that pressure is not the same as force. Let's consider the air molecules in the Earth's atmosphere. Because of the weight of the air in the Earth's atmosphere, the pressure of the air at sea level is around 15 psi, or pounds per square inch. In physics, we typically use the units of atmospheres, newtons per meter squared, or pascals. Standard atmospheric pressure is 1 atmosphere, which equals 1 times 10 to the 5th Newton per meter squared, or 1 times 10 to the 5th pascals. Fred sealed his shampoo bottle with an air pressure inside of 1 atmosphere. When the plane takes off and the altitude increases, the atmospheric pressure decreases. There is less pressure outside of the shampoo bottle than inside it. That means that for the same area of the bottle, there is a greater force inside than out. The result is that the shampoo is forced out of the bottle and it makes a big mess. Let's consider a more extreme example. It is far into the future and Fred is making a trip to Earth's colony on Mars. He is bringing his bike so that he'll be able to get some exercise once he gets there. He realizes that he will have to weigh it down pretty heavily because of the weaker gravitational field. Before his trip, he pumps his tires to 40 psi. Let's assume our future spacecraft can maintain the Earth's atmospheric pressure during the trip. When he gets to Mars and takes out his bike, what happens? Think about what happened to his shampoo bottle on the airplane. The pressure in outer space is essentially zero. Mars is not much better, with a pressure of 0.006 atmospheres. His tires will hold a pressure of 40 psi in gauge pressure. I'll explain that in a few minutes. For the same surface area of a tire, the force pushing out was greater than the force pushing in. The tires will expand. Poor Fred, his tires were old and they popped. Before the tires popped, what was the difference in pressure between the air in the tire and the Martian atmosphere? It may surprise you to know that it was not 40 psi. Tire gauges are mechanical devices that make measurements of the pressure pushing out of the tire. At the same time, there is atmospheric pressure pushing into the tire. The tire pressure will be the absolute pressure, that is, the pressure measured from zero. And it will have to overcome the atmospheric pressure to create the gauge pressure. So the absolute pressure is 55 psi. And it will push against the atmospheric pressure, which is 15 psi. The result is the gauge pressure. Absolute pressure minus atmospheric pressure gives us the gauge pressure. We use two terms for measuring pressure. Absolute pressure is the actual pressure measured from zero. Gauge pressure is the measured pressure relative to atmospheric pressure. The equation for gauge pressure is gauge pressure equals absolute pressure minus P naught, which is P naught stands for atmospheric pressure. So when Fred measured his tire's gauge pressure on Earth to be 40 psi, its absolute pressure was 55 psi. On Mars, the difference between the pressure of the Martian atmosphere and the tire would be 55 psi.